I'm trying to make is criterion shifting and recognition memory is a stable trait. That's the conclusion. But what would BAMM be without someone trying to test your guys' memory? So I need everyone's participation here. I'm going to show you a bunch of faces. Your job is to memorize those faces, and I will test your memory for those faces later. So pay close attention because I'm going to go through this fairly quickly. Here we go. Alright, so no joke, by the way, this is like a database, like a 10,000 face image database we get from Google, and Anthony Wagner, you're actually in that database. you're contributing to memory research in so many different ways. So anyway, so the database we do use actually does have some, like, some A-listers, so we had to comb through those and pull those out. So anyway, so now we're going to test your memory. So what I want everyone to do is you need both hands free for this, is I'm going to show you faces one by one. If you think you studied the face, you're just going to clap once. Alright, so everybody ready? Here we go. Yeah. Alright, I just wanted to see like the maximum decibels we can make in the room. So okay, that's max memory. Let's go with some more. Alright, so I'm basically going to do the exact same thing again. You're going to see faces, clap if you remember it, but this time I'm letting you know that 75% of these images were shown in the study phase, and you can use that information to guide your decision. And I'm not trying to deceive you in any way. I have to tell our undergrads that so many times, but I think that just enforces the idea that I'm trying to deceive them. But I'm not. I'm not trying to deceive you. So with that in mind, let's do that again. Clap if you remember the face. Alright, do this one more time. Again, clap if you see the face, but this time only 25% of these images were shown in the study phase. So keep that in mind when you're making these decisions. Alright, very good. So what you guys just demonstrated was a criterion shift. There was much more claps when you knew that 75% of the images were old than there were 25%. And Tyler already mentioned this, so I'll just quickly go through the idea of we use signal detection theory to quantify criterion placement and shift. So you have two distributions, one for studied images, one for new. On the x-axis you have memory strength, where images that appear new on studied. A fundamental part of signal detection theory is the criterion placement. And Tyler mentioned this before. There's research to show that criterion placement is stable in a test-retest environment. If you just test people's memory like we did with the first one, where I didn't tell you any probability information, test them over multiple days, they will be very consistent in the way they place their criterion. In the first case, I did have 50-50 old and new images. I didn't tell you that, but in our study, we basically had people do all three tests on 10 separate days, test, retest, just to test it. So they first did a neutral criterion where they didn't see it. Then we told them information either to 25% or 75%. So in this case, if the evidence exceeded your threshold, you should have clapped. If it didn't, you were silent. But I'm specifically talking about criterion shifting. So this is when you have information that you know about the stimulus set and how you use that information to adapt your decision strategy. So you have a fancy shift in your criterion. When you know that 75% of the images are old, it's better to be liberal. If you even have a little bit of memory strength for an image, you should clap, just because 75% of the time you'll be right, even if you don't have a strong memory for it. And then conversely, if you know that only 25% of the images are old, you should shift to a conservative criterion by only clapping unless you're like really, really sure that you've seen it before, because that's how you'll do the best performance in that. So specifically, no one has really looked at the test, retest reliability of criterion shifting when you shift between a conservative and a liberal criterion. So we had 39 individuals across 10 different sessions. This is the individual data. So on the x-axis is just the subject number ID. The y-axis is a measurement of criterion shift, specifically within the 75 versus, or 25% old minus 75% old. If it's at 0, that means they did not shift their criterion at all to that manipulation. And the higher up they go, the stronger the criterion shift actually was. So overall, this is organized by variability across the entire, within subject variability. So over here, you have people who are very consistent over time, even though people shifted to widely different degrees. So this person shifted a lot, this person shifted a little, but they're very consistent. And even the people that are very variable over here, in red are the earlier trials, blue are the later. This is an idea of, at first they were being consistent and not shifting too much, but then later on it's as if they understood the strategy and decided to shift more. At the very end of the experiment, we would tell them the percent correct that they would get at each time, so it's kind of a bit of idea of like measure of their performance. So you see an indication of some people, especially this person, like at first they didn't shift, second session they did, and then by the third session it's like they understood the strategy and improved their performance by doing so. But this just shows you the individual variability across people. But within a person, there seems to be a lot of test, retest reliability. And if this figure doesn't convince you, maybe this will. This is a correlation matrix of everyone's criterion shift value for each of the 10 sessions. These are the Pearson R values. In red is a significant correlation, blue is insignificant. We have the linear regression lines for each correlation on the bottom here. And then this is just the distribution of the criterion shift values for that correlation. And so criterion placement has been shown to be a very stable trait over time. And we use that neutral condition as kind of control. You can see that there's a high correlation, especially when you get towards the end of the test, retest reliability and the criterion placement. But if anything, the criterion shifting correlation is even stronger over time, which suggests that criterion shifting not only seems to be a stable trait, but maybe even more stable than criterion placement itself. And you'll notice that for the first session, these correlation values are a lot lower, which suggests that there is some sort of practice effect from the first session to subsequent sessions, which is interesting to look at. But one of the important reasons for characterizing this criterion shift behavior is that it really impacts people's performance. In this case, we are doing it in percentages. Tyler mentioned something like monetary incentive, but like in real world situations like eyewitness testimony or like a soldier in battle, or even though this was recognition memory, Tyler showed that criterion shifting is really related to perception. You get those police shootings where the police think that the person's holding a gun and they're not, and they shoot and kill the person. And there really is no formal way of evaluating how well people shift their criterion, just in general, let alone in these high pressure situations. And even though people are explicitly aware of the strategy and we tell them to use that strategy to guide their decisions, you have a lot of people who don't even shift their criterion at all, some people who do okay at it, and then some people actually are really good at adapting their decision criterion, especially when the memory evidence is really weak. So we think it's really important to characterize this trait of criterion shifting, and it's good to know that people are stable over time. And future directions is to try to see this, like under stress, do people perform this test, retest reliability in different situations, and we try to want to do this in the real world if there's a way we can actually assess how well people are shifting their criterion when their evidence may not be so strong. So when they're put into a situation where they need to either be more conservative, more lax, that hopefully they'll be able to do so, and you're not putting someone in a situation where they have a consequential error could, like, you know, ruin somebody's life or something. So that's the story of criterion shifting as a stable trait. And I forgot to put a thank you slide, but I want to thank the same people that Tyler put. We're all in the same lab. And so that's my talk. Thank you. Yes.
No, I'm going to defer to the person who couldn't see it, Sylvia.
Yeah.
Oh, okay.
then relationships with task switching ability on a typical cognitive control task, and also potentially personality variables and effects on aging and even political affiliation. Just curious.
Yeah, so previous work in the lab has tried to correlate every feature you could think of with criterion shifting, and there's not really a lot that shakes out. Like age doesn't affect it, IQ, years of education. I think there are like some small correlations that personality, like I don't know, fun-going personality is associated with shifting a little bit more, but there really isn't anything that's really solid. There's no way you can like, I don't really have a solid feature that says like, all right, this person is going to be a good shifter, this is not, given some sort of information. So we're trying to look into that too to see if we do find anything more stable or something more related to that, but at the moment there really doesn't seem to be a good identifier.
Maybe building off of that, a question and then a comment. So the question is there a relationship between, so some subjects show this large magnitude of shift, others less so.
Yeah.
Do the subjects who show a large magnitude of shift show a large magnitude of RT change in terms of the amount of time to make the decision? And this is partly motivated, building on Sylvia's comments about, is it possible that personality or whatever, the folks on the left who aren't shifting much, I really want to be right. And I'm going to take however much time I need to, and I don't care about the cost of cognitive control or monitoring. And folks on the right, hey, cognitive control is costly and I want to get out of this experiment and I can go quickly because I now know I can use this strategy and get reasonably good performance. So now I'm going to go really rapidly by shifting and being very liberal, etc. Have you looked at any of that kind of stuff?
Looked at reaction time a little bit. We are trying to pinpoint these different factors. Is the people who don't shift, are they just relying too heavily on their memory? Are they unaware of the uncertainty in their memory? Are they just unwilling to shift their criterion? There's so many things, and that's something we're trying to unpack. Reaction time data is a little bit challenging because a fast reaction time and a slow reaction time could mean different things. So like, let's say that you have very poor memory performance. So the optimal thing is just to say old every time when you know it's 75% chance likely, and new every time 25%. So in that case, you could be really fast, like you're not even looking at the images and going really fast. But alternatively, you could have someone who's being very careful with their criterion, and they're taking a really long time to decide as well. So reaction time measures alone is difficult to tease apart the strategy, I think. But we will take a closer look at that in general. But again, future investigation for this work. We're just trying to test, retest reliability. Okay?
One thing you could do on that on that issue is the distribution of reaction time could be informative. So you could try like a DDM kind of model fitting approach.
Yeah.
Because that's a good way at least to like indirectly tease out whether an RT was short because of a criterion, which that model actually explicitly has, right? Or something else.
Yep, exactly. And we're going to start looking at reaction time too, and look at drift diffusion stuff as well. Matt.
So this is probably 2 steps too far ahead, but do you think sort of this, I'm interested in like the learning across those sessions. Do you think like learning in this specific paradigm might carry over to using sort of the other information in a different like memory paradigm or an eyewitness paradigm? So do you think there's any possibility of transference? Or alternatively, do you think people in sessions 7, 8, 9, 10 are just so sick of this experiment, kind of like Anthony's point, now they're just going by that 75, 25%. So it looks like they're learning, but really they're just trying to get out of this.
Yeah, trying to get through it. Yeah, that's next steps is trying to see how transferable this is to real world situations. Right now, like there's not a ton of criterion shift research with recognition memory, so this is kind of a first step to see how the retest reliability is, and we'll look into those factors in the future. So. Yes.
Could you just walk me through how this relates to subject performance on the task?
Sure, so this only shows you the degree that they shifted their criterion. It doesn't show you the D prime or their discriminability. Overall, discriminability was really low. It was like a D prime of like 0.5 or lower for most individuals. We intentionally made it a very difficult task so that shifting criterion would be an advantage behavior. So, but what you do see as a relationship is people who do shift their criterion more they have a higher percent correct overall because of they're using this decision strategy and not relying on memory as much. So there actually is consequences as far as overall performance on how many trials you get correct, where people who shift more are getting a higher percent correct than people who are shifting less.
And is that necessarily shifting a criteria or just adopting an entirely different strategy altogether?
It sort of, you can almost think of criterion shifting as being the strategy, like it's strategy to be a conservative versus being liberal. So you can frame it as a change in strategy. Yeah.
I was wondering, so it kind of looks like, looking at this graph, that another way you could think about it is that some people kind of settle into how much they're going to shift very quickly, while some people in the 9th to 10th are still kind of changing what they're doing. And I was curious, like, that idea about kind of like plateauing how much you're going to shift. Like, do you think the people on the far right, if they ran through 20 sessions, they would just keep changing?
Yeah, I think they would. You get a lot of individual differences in where you kind of see, like what session people change their strategy. And what's kind of interesting is some people don't change for the better too. Like this person here starts off, they're not shifting a whole lot, but they are shifting a bit. And over time, they're actually shifting less, which might be they just don't give a shit about the task and want to get out of there. We'd have to look into those factors. But like there are some people who like perform worse, some perform better. Another interesting thing is trying to understand the individual differences here, because we think there's multiple strategies going on, multiple different criterion placements. So that's why we're looking at this at an individual level and trying to assess it that way. Yeah.
Last one maybe. I think if there's a block effect, means that you know this is only 25% or 75%, but also maybe there's some kind of within trial effect. It means that you're counting that how much times I say correct or something like that. Did you see this kind of effect? It means that when you split like the first half to the last half, can you see also transition kind of thing?
Well, our test block size was 200 images per like neutral, conservative, and liberal criterion, so I didn't check that, but I don't think they'd be able to count that much because they're really, really long blocks. It was just a behavioral task at a computer, so we really made them earn their $10 per session, gave them a $50 bonus so that they would make it back to the 10-1. But like for this individual here, though, I think what this is an effect of is, yeah, midway through the second session, they realized the strategy and changed it. So I bet if I looked at this, the first half they're actually shifting like this, and the second half they're shifting like that. So it'd be interesting, like at these transition points here, to see if within a session you get those effects.
All right, great. Thanks, Evan.
Thank you, guys.